Neha. I am a student of Basic Chemistry Honours second semester, and I am here for explaining the topic from organic chemistry, that is of alkenes. So let's get started from the preparation of alkenes. We can prepare alkenes firstly from the dehalogenation of vicinal dihalides. That is, for example, if we take 1,2-dibromoethane and treat it with zinc in presence of alcohol and then heat the mixture, then we will get ethene as the main product and ZnBr2 as a side product. The mechanism of this reaction can be explained as follows. So first of all, let's draw the structure of vicinal dihalide that we have taken. This is the reactant we have taken, which is to be converted into alkene in its corresponding alkene form. So here the zinc attacked the bromine atom, which in turn gives us its electron to the carbon atom to which it is attached. These electrons are further transferred to the CC bond of our vicinal dihalide like this. And now, to maintain the octet rule, this carbon atom gives this bromine atom its electrons back, which results in the elimination of the bromine atom from this carbon atom. Hence, we can say that this whole process can be described by a single transition state, which can be drawn as like this. Partial negative sign on bromine atom, partial positive sign on zinc atom, double bond character in between the CC bond, and partial negative character at this bromine atom. So this is our transition state of the reaction, which leads to the formation of ethane plus ZnBr2. We can also form alkenes by the dehydration of alcohols. So let's take for example CH3CH2OH and treat it with 95% of H2SO4 at 453 Kelvin. We will get ethene as the main product and water as the side product. Mechanism of this reaction is As we all know that alcohol is a Lewis base which readily accepts a proton from the strong acids like H2SO4 to form a molecule of protonated alcohol, that is oxonium ion. CH3CH2. Here two lone pairs of oxygen atom, H positive liberated by the strong acid. Here we have taken H2SO4 for instance. Now these lone pairs attack the H positive and this alcohol forms a protonated alcohol molecule like this. Now, oxygen being electronegative atom, here possesses a positive charge on it, which weakens the CO bond, and thus it readily eliminates a molecule of water, forming a carbocation. So second step of the mechanism is formation of carbocation. Here CH3CH2. This protonated alcohol gives a water molecule to form a carbocation. This is 1 degree carbocation, that is now this carbocation formed here is a reactive chemical species, eliminates a proton from beta carbon atom to form an alkene. The loss of the proton may also be assisted by the base, that is HSO4 negative ion or another molecule of alcohol. So the third step is elimination of beta hydrogen to form alkene, that is CH2 so this is hence this beta hydrogen atom gives its electron and gets eliminated in form of H positive, that is proton, and we get alkene, that is ethene, as the final product. Sometimes it may happen that instead of formation of normal expected product, some unexpected products may also be seen. For example, if we take the example of N-butyl alcohol, that is, and this H positive will give electrons to the carbon atom to which it is attached. Furthermore, these electrons get transferred to the CC bond of our compound, and finally leads to the elimination of tertiary amine, which is NCH3 whole thrice. This reaction takes place through E2 mechanism, or we can say E2 reaction. In this, we get our required desired alkene as the main product and tertiary amine, that is CH3 whole thrice N plus H2O, as side products. So this method can also be used for the formation of alkenes. Now let's see the chemical reactions carried out by these alkenes. So first of all, we will study about the addition of halogens. Let us take an example of a simple alkene, that is ethene, and let us treat it with bromine molecule in presence of a non-polar solvent, that is say CCl4, which leads to the formation of vicinal dihalide, that is 1,2-bromo ethane, 1,2-dibromoethane. Similarly, we can add other halogens such as chlorine, iodine, fluorine. The reactivity order of addition of halogens to alkenes is fluorine, chlorine, bromine, iodine. That is, fluorine reacts with alkenes too rapidly as compared to others. The mechanism of this reaction is very simple. As we know that bromine molecule is non-polar, but when it comes in the vicinity of the ethylene molecule, that is CH2 double bond CH2, it becomes a polarized bromine molecule, that is partial positive and partial negative signs are induced within the molecule, which further helps to promote the reaction. Now, after the induction of polarity in the bromine molecule, the reaction works faster. Now, the partial positive and partial negative charge separation in bromine molecule occurs, due to which the double bond having larger electron density attacks on the partial positive side of the bromine molecule and hence forming a carbocation as follows. This is a slow step. Now, here Br negative ion attack this carbocation as follows. CH2, this Br negative act as a nucleophile and attack on the positive side of the carbocation so formed. This is the fast step, thus forming 1,2-dibromoethane. Now let's study about the ozonolysis of alkenes. So when any alkene is treated with ozone, like for example, take let us take ethene plus ozone in the presence of CH2Cl2 at the temperature of 196 to 200 Kelvin, we get an unstable adduct, that is CH2, CH2. Here the oxygen atom, oxygen linked with this carbon atom. This is unstable in nature. Which further gets converted into this compound, that is ethylene ozonide. So on ozonolysis of alkene, we got ethylene ozonide. Now hydroxylation of alkenes, that is, if we treat any alkene with KMNO4 in presence of water, it gives, like for example, here we have taken an ethene molecule with KMNO4 and water. It gives us CH2OH, CH2OH, which is commonly known as ethylene glycol, along with the formation of MnO2 and KOH. Here, this MnO2 is characterized by its brown PPT and as we all know that KMNO4 is purple color. So this reaction can be used as a test for unsaturation and its commonly it's known as by the name of Bayer's test. In this, the purple color of KMNO4 turns into brown PPT, which indicates the presence of unsaturation, that is alkenes, can be alkenes in this case